ในเซสชันเช้าของวันนี้นะคะหัวข้อสุดท้ายก็จะเป็นหัวข้อที่ชื่อว่า Manufacturing Solution Technology Update นะคะนำเสนอโดย Mr. Santhosh Nagaraju ค่ะท่านเป็น Senior Technical Specialist ของบริษัท MSC Software นะคะในหัวข้อนี้นะคะขอเรียนเชิญ Mr. Santhosh ค่ะ
Good morning, all. I'm Santhosh Nagaraju. So I take care of technical and BD for manufacturing process simulations softwares. So I have experience working on shop floor as well as using CAE tools. So today I will not go in detail into product, but I will majorly focus on what are the new updates in forming, welding, and additive solutions. So let's begin. So when we say virtual manufacturing and costing, so it includes multiple solutions from us. So if we are into early feasibility, in the sense if we are into the costing of any sheet metal component, so we have a cost optimizer. So where you can estimate the cost of a component or sheet metal component, considering the material requirement, process cost, and the rest of the cost involved during manufacturing. So if you're more interested in understanding how these components are getting manufactured with the different ways, like it might be of sheet metal, then you can go to forming suit, which gives you idea of how this particular component is formed. So if it is of sheet, then you can go with the forming suit. If it is of bulk forging, then we have Simufact forming, where you can simulate bulk forging operation, which is of open die forging, closed die forging, ring rolling, heat treatment, any of the conventional manufacturing process. So then we have Simufact welding for simulating any welding process simulation. So then comes the advanced, or we call it as latest technology called 3D printing and additive manufacturing process, where we talk about metal 3D printing, then optimizing for additive manufacturing, so which is of more apex generative design. So if you're working on joining, like mechanical joining and riveting process, then we have Simufact joining as well as optimizer. It can tell you which is the best way to rivet. Also, you can estimate once you do the riveting operation, so what will be the strength of that particular rivet joint. You can do the riveting process simulation as well as durability and strength analysis on the riveted structure. So overall, any metal-based manufacturing process simulation can be estimated, in the sense you can estimate the cost for any of this process. Same time, you can simulate, optimize, or improve the material yield. So you can simulate any of metal-based optimization process. So let's go in detail. When we are talking about conventional manufacturing process, so you might be working in any of this area. So starting from hot forging, cold forming, open die, ring rolling, shape rolling, sheet metal, heat treatment, or any of mechanical joining process. So we can simulate the process. So I just put each and every operation inside this different category. At the same time, you can switch between 2D to 3D. For example, if you are doing a offsetting operation, so you can do it in two-dimensional analysis, so that you save a lot of simulation time. Then when it comes to the ring rolling and other process, then you can switch it into 3D. So software gives that option to switch between 2D and 3D, so that you will save a lot of simulation time. So apart from that, we do have option to take input from different software solutions like Magma, Procast, and for the material properties. So these are the different operations we can address. It might be of any metal-based manufacturing process. We can simulate and understand how best we can utilize the available resources. It might be of we have a machine ton capability of 20 tons. So how to use that particular machine for the given workpiece dimension, or is it really required to use higher press and capacity? All of this can be estimated with the simulation software. This is an example of connecting rod, how it is done on the shop floor. So how we can replicate in the simulation solutions. So we can have the exact digital twin. So how it is happening on the shop floor. So we can create the same in the software so that we can understand the defect. We can understand the material utilization flash. So also we can work on different grade chains, flashless forging. So all of this can be tried with this. So what is new? So this quite might be interesting for you. So in the latest version, so we added new tetrahedral element. So also we have added damage modeling. If there is a crack during forging operation, so it can predict the damage. Then other improvements on a solver for the better runtime. Then we have predicting the properties or mechanical properties under loading condition and exporting results to the other file. Exporting result in different file format to be used in third-party software. So CAD import has been improved. Like we have added new CAD file format which can be used in Simufact forming. Then geometry check. The most of the time, the simulation used to abort because of quality of geometry or improper CAD model. So now we can check the quality of geometry so that we will not have any issue during convergence. Then comes the shape comparison. So once the operation is complete, so you can use your initial CAD model to compare the deviation from original design to the simulated one, or original CAD to the actual part, which is with deformation and shrinkage. So these are the new updates in the forming. So when it comes to sheet metal, so we have two different set of solutions. So if you're more interested in one-step solution, so then you can go with FDI forming suite, where you can have the number of stages, nesting, and material utilization. But if you want to go in deep into the process, like kind of incremental solver, then you can go to the Simufact forming. Then you can go in detail into the formability process, like what are the different formability stages, then how material getting elongated in the each stage. So all of this you can get it from the incremental solutions. So this is an example. So if you're more interested in only forming of a component, so if you're not interested in die shape and other parameters, then we suggest you to go with the forming suite. Then if you're more interested in understanding FLD, die wear and tear and other parameters, then you can go with Simufact forming. These are the different bending operations. So now the solver has been improved. So bending simulation, when it comes to bulk forging, was a challenge. It was taking a lot of time for solving. So now it has been improved with the new elemental and solver type. So all bending process can be run much faster than any tools available in the market. This is a wire drawn simulation, so which we have recently done it with the latest version. So even it has much faster convergence. So these are the example of how it can be used. So I will go to welding and joining. So when I say welding, so we can simulate any type of welding process. So it might be arc welding, laser welding, electric beam. So even the direct energy deposition (DED) technique, then resistance, spot welding, brazing, and even the heat treatment or stress relieving and clamping and unclamping sequences also. So these are the examples. So why it is important? So when we release the welded structure at different interval of time, so we could see different residual stresses and distortion in the component. So we can even define the clamping forces so that it is more realistic to the physical experiment we do it in the shop. So who are our customer and motive? So welding is majorly, you can name any of major car maker in the Europe or now throughout the globe. So they are using our solution for the welding process simulation. So majorly, the major challenge comes when we are defining a welding fixtures and welding sequences. Like if I have a 3 robo and if I have a different set of fixture with the different clamping forces and clamping and unclamping and cooling time. So how my part will be, how my part will distort during the process as well as after the process can be simulated from this. So this is an example of how the stresses are getting generated during welding process and how the temperatures are getting generated during welding process. This example of Audi car door. So when we have 4 different robots welding from a different path, so how distortion looks in each welding sequence. So let's say I have 4 robots welding the car door, and it start the one sequence start left to right, the second one right to left. Like that, we can interchange and do a lot of DOE study so that we can understand which sequence gives the minimum distortion and better control on the residual stresses. So all of this trial and error can be done with welding. Yeah, joining optimizer. So it suggests you which is the best riveting sequence. This is an example of JLR. They have could able to reduce the different 246 different material stocks in one car. So which helped them really to save a lot of money when it comes to physical trial and error. So all of those was done in simulation software. Then they went for actual or optimum riveting process. So not only just riveting, so even after riveting, you can just have the pull test to understand. It might be of riveting clamping to understand how best it can withstand the load. So this is optimizer. So now we have welding optimizer, so which can be used for any existing welding processes. So what is new in welding? So now we have improved DED, direct energy deposition technique, where you can see the current, weld path. So in which direction it is welding and effect of current weld path on the rest of the component. So then you can, so runtime is a challenge when it comes to the welding. So now you can monitor, so which iteration take more time and what were the challenges by process capability and solver time monitoring, so that you will have the clear understanding whether it is heat treatment or whether it is welding at particular location is taking more convergence and what could be the reason for that. Then we have export option. So this is one of request from the many customer. So after welding, they wanted to do the structural strength or durability analysis. So they wanted to export these results along with the results for third-party software. So now we have introduced UNV export option in the latest version, so that you can directly export in UNV file format and use it in any other tools for the durability or strength analysis. So apart from that, a lot of improvement on importing G code if you are doing a direct energy deposition method. So on metal additive, so our previous speaker has already given a lot of information on how metal additive works. So I will just quickly go through what is new in this Apex generative design, which is optimizing for additive manufacturing. Then Simufact additive, what is new in Simufact additive. So Apex generative design, it's easy to use and simple tool. So where there are a lot of manual effort in terms of cleaning geometry and meshing was reduced, in the sense it can automatically clean the geometry and give us the STL file, or even we can convert that STL file into step file. so that it can be used in any CA tool for further analysis. So what is new in latest version? So one is we now have a material property based on the different directions. So if you're working with a composite material, so with the FFF or FDM process, so now you can consider those material and do the optimization for the polymer or composite material printing. So previously we were only using a metal material or powder material for the optimization process, but now we can consider the different materials which is of polymer material also during for the optimization process. At the same time, you can define the failure criteria in each direction so that it can consider the failure criteria during lightweighting or topology optimization process, so that you will have better control on the design, so that you need not to really go for in detailed durability analysis. So then we added manufacturing method. For example, you are doing a lightweighting or topology optimization. So you can select what is a process or manufacturing method. If I do the lightweighting of a component, will I go with 3D printing or powder bed fusion? Will I go with different material printing with different printing conditions? So those manufacturing condition can be considered here, so that the manufacturing principle will be considered during optimization stage. Then comes the NURBS geometry. So this might be quite interesting. So if we have any CAD file, if you want to convert that CAD file into any other format, so it can be done with the NURBS option. Or even if you have a solid file or STL file which is non-editable, so you can bring STL file. Then you can convert that STL file into step file or Parasolid or XT, whatever format you want. It can be converted into editable file format using NURBS option. So this is one of the features used by most of our customers, because sometimes they have a STL file from design department that is not allowed to do any, or we cannot do any design changes. In that case, you can use an NURBS geometry, convert those files into editable file format, then you can do the any geometry modification. So that is available with the 2020 and above version. Then conversion. So now it has further improved. Previously, there used to be manual selection of surfaces and curvature. So now it is further improved. At the same time, you have different options available where we can do the remote loading, and the lot of visualization has been changed. Yeah. So when it comes to the additive manufacturing, so most of challenge for any 3D printing bureau or additive manufacturer, so they wanted to reduce the material consumption in the form of reducing the support structure, or reduce the supports, so that the less material will be consumed, as well as they can reduce the cost. Also, they can manufacture it with a faster rate. So what we have done is we introduced two new features. One, we added CAD additive support generation. So along with Simufact and Materialize Magic, so now CAD additive supports are available in Simufact 2021 version. So you can use a new set of support structure. This looks like this. So you can use block support, then block with different type of formation. Then you have tree root structure, or we call it tree structure, and in place of regular liner block support. So this comes along with now user has option to select 3 different support structure. One is of Simufact, then Materialize Magics, and CAD additives. So under that we have different set of types of supports. So based on different part geometry, you can pick the one which is more convenient for you. The next option is generative design support optimization. So once I have generated the support, so I can do further optimization of support, because when I say support generation, it considers only the geometry parameters, but it will not consider the thermal effect and other manufacturing or process effect. So now we can do the further optimization of support considering the manufacturability. So that is generative design support optimization. So these are the different set of optimization we can do it for a support structure. So it helps us reduce the material for support, also easy removal of support from part and base plate, and a lot of other improvements on rerunning the simulation and other parameters improvement has been done in the latest version. Okay, so with this I end my presentation.